Good day to everybody. Garrett and I are researchers of the Italian National Research Council. As you can see from the title, the aim of our contribution is to analyze the diffusion, application, constraint and performance of the implementation of Industry 4.0 in the Italian automotive supply chain. As you know, the automotive supply chain is a global industry historically characterized by high fragmentation of production, by the presence of both international and local ties, and strong needs of investing in digitalization approaches. The background of our contribution comes from a presentation at the PISA conference 2 years ago by Morgan and Curry, where they argued if Industry 4.0 can spur upgrading the automotive supply chain in Canada, that they defined as a semi-peripheral country in the automotive panorama. You can find this paper on the last issue of our International Journal of Automotive Technology and Management. Our contribution is also related with a presentation 3 years ago by Tommaso Parri about the concept of the fourth industrial revolution in the automotive sector as a good example of the limits of these technologies, defined by the literature as disruptive. According to Pardi, there is an array of technological, organizational, and economic obstacles. Unfortunately, the Italian automotive supply chain confirmed the critics shown by Morgan, Curry, and Pardi. According to the Morgan and Curry scheme, semi-peripheral automotive countries are those without a domestically headquartered car assembler. This is the principal attribute of core automotive countries like the US, Germany, or Japan, and without low-cost labor, the distinguished feature of the group of countries defined as the automotive integrated periphery, that include Mexico as well as countries in Central and Eastern Europe and Spain. Of course, China and India are the exception that confirm the scheme. Automotive semi-peripheral countries are also characterized by a broad base of automotive manufacturing, well-educated workforces, and headquarters located on at least some large automotive parts suppliers. All features considered to be supportive of the introduction and development of the complex process and system of Industry 4.0. More than Curry have included Italy in the core group for the presence of Fiat Chrysler, but after Stellantis merge, I'm not sure of it. Before verifying the position of Italy, let me show you this figure. We can see the trend of the sales in terms of volume and turnover. The data refers only to suppliers and not the car assembler. Starting from the financial crisis of the last decade, it's evident that Italian suppliers were more focused on export, the blue line, than the domestic market, the green line. But if we move the starting point of the graph at the end of the second financial crisis, more or less 10 years ago, we can observe a change with predominance of the domestic market, the green line. But from 2018, the domestic market finished to be attractive. What did happen? In my opinion, the new situation is related to two events: the death of Marchionne and the Stellantis merger. As a matter of fact, the connection between the Italian supply chain and Stellantis becomes weaker and weaker. So, in my opinion, Italy is more likely moving towards a semi-peripheral automotive country. The other variables partly confirm this impression. The ratio of R&D on turnover is low, 2.6%, even if about 70% of Italian automotive suppliers stay to invest in R&D. As Tavares said, labor cost is low in Italy, on average 51,000 euro, but energy costs are higher, about 28% more than the other EU countries. The presence of foreign suppliers is relevant. They cover 18% of value added and 55% of workers. Finally, in the list of automotive news of top 100 suppliers, there are no Italians. In terms of turnover, the largest Italian firm is Brembo, specialized in premium brake systems. So, generally speaking, the primary source of competitive advantage for retail is not power, but could be flexibility. I suppose that all of you know what Industry 4.0 is. More important is focusing on the expected benefit from the introduction of these technologies. In particular, it's expected a greater flexibility of process and production that will allow to combine the needs of variety, mass customization, and speed of response to the market, with those of productivity without sacrificing the quality of products. The Italian automotive suppliers have the possibility to upgrade the position, to strengthen and to integrate the network of supply, and to redesign the productive and organizational processes. Industry 4.0 could allow to improve efficiency and innovation, and therefore to stimulate demand, and in the midterm maybe favor reshoring. Let's see the methodology of our presentation. The sample does not refer to the Code 29 of the Standard Industrial Classification, but includes all firms supplying in the automotive industry. Just a bit more than 2,000 enterprises were investigated in the period 2017-2020, and we collected the answers of 866 companies. A key trait of the Italian automotive supply chain is the prevalence of small and micro enterprises, about 50%, and mainly specialized as a component supplier. To analyze implementation of Industry 4.0, we have adopted a traditional mode of analyzing the industrial organization, that is the structural, conduct, and performance paradigm. For each dimension, we select a peculiar question and analysis, that is, who has implemented Industry 4.0, in which department, which technology, which are the constraints in adoption in Industry 4.0. About performance, we use company database with financial information to evaluate the impact of Industry 4.0 on employment and productivity. About the structure of the implementation of Industry 4.0, this table shows that more than 72% of Italian automotive suppliers have implemented something related to Industry 4.0, with higher percentage for the system and module suppliers and component suppliers, and lower value for engineering and design. To reply to the question who has adopted Industry 4.0, firstly, we use the correlation index between determining if the supplier adopted or not Industry 4.0 technologies and the list of variables. Secondly, the same variables were used altogether in a logic model to confirm the correlation index. About the variables, some concern the automotive industry as the percentage of turnover towards the automotive sector, so to verify the level of diversification, or the percentage of turnover towards Fiat Chrysler, so to verify the dependence from the national car maker, and tire level in the supply chain. Other variables concern structure of the supplier as export intensity, R&D investment, production capacity, the percentage of graduate workers and sites. Finally, we use also some dummies about the foreign ownership, if the companies have patents, if they are part of the network, and if they have projects in electrical connected vehicles and so on. Let's see the correlation indexes. The table shows in black the negative coefficients and in red the positive one, and also by the stars the free level of significance. As you can see, most of the variables are positive and significant. Of course, the tire variable has to be considered in the opposite direction. Peculiar to see the negative impact, even if not significant, of the variables related to the involvement in the automotive industry. The econometric logic model is more precise than the correlation index. The dependent variable is a binary variable, that is, if the supplier invested in Industry 4.0 or not. The logic model confirms most of the results of the correlation indexes. In comparison to the correlation indexes, the percentage of production capacity, tire level, and foreign ownership change the sign, but only the last one remains significant. That is, suppliers controlled by foreign holding are not interested in upgrading the Italian controlled company. The percentage of graduate workers, size in terms of turnover, be part of a network, have projects in new trends are the variable with a positive coefficient and significant. That is, larger firms with skilled workers and invest in new vehicles detect a higher probability to invest in Industry 4.0. The negative impact of the variables related to the involvement in the automotive industry are confirmed, even if they are not significant. Let's move to the conduct adoption of Industry 4.0. As expected, production is the part more involved. About 50% of Italian suppliers adopted technologies in this area, followed by other line departments as quality and logistics. Staff departments as maintenance, supply chain management, marketing have been less involved. These results show that in the Italian automotive supply chain, Industry 4.0 is still limited to production and there is not low interaction with the other departments. This table confirms the former figures. The technologies more introduced seems the less challenging, as production data analysis, sensor, traditional robots, human-machine interfaces, and automated plants. The more disruptive technologies as machine vision and material tracking are under 30% of introduction, and core robots and three-dimensional systems are under 20%. These results indicate that the most automotive companies are adopting the basic tools of Industry 4.0, but are delaying investment in more advanced and expensive tools. If we compare the results for the total sample and the 5 specializations, in this case red boxes show the value above the average of the Italian supply chain, the most active supplier group is investing in Industry 4.0 is the system module, that have invested quite more in all technologies. The gap with the other suppliers group is substantial, in particular with the component suppliers. The difference is 15–20% points for the more disruptive technologies and 5–10% points for the less challenging technologies. Another important aspect is to count the number of technologies introduced by each supplier. About 5% of suppliers introducing only one technology. About 9% of suppliers implemented 2 technologies, and we detected roughly the same percentage up to 7 technologies. One supplier it introduced all Industry 4.0 technologies. The main constraints in the implementation of Industry 4.0 seem related more to internal situation. For about 60% of the suppliers, the main obstacle is the investment cost, followed by the lack of company culture and internal resources, each at about 30%. External difficulties have been less considered. In this table, we cross the constraint with the size. Again, red boxes show values higher than the average for the Italian supply chain. The major differentiation concerns large firms compared with the other 4 groups. For the large enterprises, the main limits are external, which results from the lack of economic state heads and legal risks. Investment cost and lack of internal resources have been more cited by micro and small companies. To summarize, the conduct of the implementation of Industry 4.0 technologies in the Italian automotive suppliers is not in line with what it is expected, and it is supposed the performance will be in some way affected. Let's move to the performance evaluation for 3 different modalities. The first one comes from the questionnaire. We ask the level of impact of the adoption of Industry 4.0 on the enterprises. According to our sample, the best impact of Industry 4.0 concerns more generic and transversal items, as problem solving, followed by production system, has increased capacity, quality, and merely work safety. Reduction of labor, industrial costs are the middle of the ranking, and higher than we expected. That is, the reduction of costs that should not be a main target for Industry 4.0. On the contrary, some abilities as creating products and services or entering new markets had a lower impact than we expected. This figure shows the employment change year on year between who invested in Industry 4.0, red histograms, and who have not, blue histograms. As we can see, in the first 3 years, those who have invested in Industry 4.0 have increased the employment, as opposite to those who have not. Even in 2020, the first year of the COVID pandemic period, although there has been a reduction in employment, the comparison with 2019 is still favorable. These results contrast with part of the literature which presume that investment in Industry 4.0 should reduce employment. For the third way to analyze performance, we compared productivity between who invested and who did not invest in Industry 4.0 before the pandemic event. We used the non-parametric output-based Malquith index to evaluate the total factor productivity of each Italian automotive supplier. The Malquith index measures the shift between the frontiers defined by the data development analysis, assuming variable returns to scale between two different years, in our case 2017 and 2019. The data development analysis measures the degree of technical inefficiency, calculated as the distance from the efficient production frontier for each supply specialization, system of modules, components, engineering designs to supplier and so on, and considering 9 balance sheet items. Value of the Malquith index higher than 1 represents improvement in productivity, and in the case if it is less than 1, we have a reduction of productivity. The econometric model is again a loaded model. The dependent variable is the Malquith dummy, that is a binary variable. If there was an increase of productivity between 2017 and 2019, otherwise if there was a decrease in productivity. The list of variables is the same as the logic model before. We add only the dummy if the supplier invested in Industry 4.0 and some interaction. That is, for example, what happens if the supplier is controlled by foreign company and invests in Industry 4.0? Or what happens if the supplier invested both in new automotive trends and in Industry 4.0? Finally, we cluster the sample by time, but this is just a technicality to render the model more robust. The table shows in black the negative coefficients and in red the positive ones, also by the stars the three levels of significance. So far, only one variable is significant, has a positive impact on productivity, that is, if a supply is part of a network. We detect a negative and significant impact on productivity for size in terms of the natural log of turnover and being controlled by a foreign company. But also investing in new automotive trend, that is electrical connected vehicles, or investing in Industry 4.0 have a negative impact on productivity. As a matter of fact, in the period 2017-2019, the Malquith index highlights that only 37% of the Italian automotive suppliers increased total factor productivity, and who invested in Industry 4.0 underperformed and garnered a mere 33%, whereas 45% of the suppliers that did not invest in Industry 4.0 increased productivity. These results confirm the party's suggestion that the fourth industrial revolution is not underway at the moment, and that a radical disruptive break will not take place in the coming years, and confirm the course is more likely path-dependent evolution trend. However, if we consider interaction, the negative outlook changes a bit. For instance, a supplier controlled by a foreign company that has invested in Industry 4.0 detects a positive impact on productivity. Similarly, a supplier that invested both in new automotive trends and in Industry 4.0 has a positive impact on productivity. That is, it's better that green transition and digital transition go hand in hand. On the contrary, a supplier that is part of a network and has invested in Industry 4.0 registers a negative impact on productivity. These results are interesting and suggest to go through in the analysis and the need to profile each supplier appropriately. Industry 4.0 is a complex matter and quite different from a traditional investment in the process or in the product. Positive interaction between new trends and Industry 4.0 denotes that only highly structured firms can reap the benefits. We are going through the analysis, but more elaborations are needed to validate the results. For instance, from the composition of the Malquith index seems that the negative impact of investing in Industry 4.0 on productivity depends on the organizational aspect of efficiency and not by the technological side. The conclusion could be that suppliers must take into account more how the new technology have been introduced to catch all the benefits. We also divide the sample in 5 different specializations, and in comparison with the other supplier groups, only system module suppliers detect a positive impact of investing in Industry 4.0 on productivity. The conclusion could be that the less structured companies have to be highly supported by consultants to catch all the benefits and not only introduce a couple of technologies. Finally, we divide the sample into 13 subgroups according to the number of technologies introduced. From the introduction of 6 different technologies, the impact on productivity became positive and partially significant. The conclusion could be that only upon the introduction of these technologies can produce benefit. Industrial policy should take into account of this outcome. Funding a single technology arbitrarily, as the Italian government did, does not bring benefits. Industrial policy should support only highly systemic investment. So, nevertheless, don't be discouraged and keep investing in Industry 4.0. Thank you for your attention.